lesson, we're going to discuss arithmetic series. Now let's first define what is series. It is the sum of the terms in a sequence. And therefore, we can say that arithmetic series is the sum of the terms in an arithmetic sequence. And the sum of the first n terms of a sequence is called partial sum, and it is denoted by the variable s sub n. Alright, so we have two formulas to be used to find the sum of terms of an arithmetic sequence. The first one is we have s sub n is equals to n over 2 times the quantity of a sub 1 plus a sub n. To use this formula, a sub 1 and the last term should be given, and of course the number of terms. We can only use this formula if the last term is identified. For the second formula, we have s sub n is equals to n over 2 times the quantity of 2a sub 1 plus n minus 1 times d. So in this case, we can use the second formula if the last term is not given or not identified. And of course, if you notice, the common difference should be given also. Let's proceed to an example. Find the sum of the first 12 terms of the arithmetic sequence 50, 47, 44, 41, 38. So first, you have to write down all the given for you easily identify what formula is going to be used. So we have a sub 1 is equals to 50, the difference is negative 3, and the number of terms is 12. If you notice, we can easily find the value of difference by means of subtracting a term from the previous. Since the common difference is constant, it's the same with all the terms. Alright, so we're going to use the second formula. S sub n is equals to n over 2 times the quantity of twice of a sub 1 plus quantity of n minus 1 times d. Now, substituting all the given, your a sub 1 is 50, your n is 12, and your d is negative 3. Solving this will give us 12 over 2 is 6, 2 times 50 is 100, and 12 minus 1, 11 times negative 3. So we have 6 times 100 minus 33, and 100 minus 33 is 67, times 6 will give us 402. Alright, so for the next example, let's find the sum of the first 38 natural numbers. So in this case, the exact sequence or exact terms in the sequence is not given. So you have to recall what is a natural number. So when we say a natural number, these are numbers starts with 1. 1, 2, 3, 4, so on and so forth. And it says here that we're going to find sum of the first 38 natural numbers. So let's write down all the given. Obviously, your a sub 1 is equals to 1. Your last term is 30, and the number of terms, of course, 30. So what form is going to use? Since a sub 1 is given and the last term is also given, we can use the first formula, which is s sub n is equals to n over 2 times a sub 1 plus a sub n. Alright, so substituting all the given, your n is 30, your a sub 1 is 1, your a sub n is 30. Solving this, we have 30 over 2, or divided by 2 is 15, 1 plus 30 is 31. Solving this, 15 times 31 is 465. Alright, so let's try this. On your paper, find the sum of the first 200 natural numbers. I will give you 3 minutes to answer this one. And your 3 minutes starts now. Alright, so for the solution on how to find the sum of the first 200 terms of natural numbers, write down the given. Obviously, the first term is 1, the last term is 200, and their difference is 1. Alright, so to find the sum, obviously n is missing, or the number of terms. So let's go back to the formula of arithmetic sequence, which is a sub n is equals to a sub n plus n minus 1 times d. Substituting the given, your a sub n is 200, a sub 1 is 1, n is unknown, and d is 1. Obviously, if we continue solving this one, your n should be 200. Because from 1 to 200, those are 200 terms. And we can now solve the sum. So we're going to use the first formula. A sub n is equals to n over 2 times a sub 1 plus a sub n. And your s sub 200 is equals to 200 over 2. A sub 1 is 1. Last term is 200. And then your s sub 200 is equals to 100 times 201. And the sum of the first 200 terms of natural number is 20,100. That's it. Okay, so for our next example, find the sum of all multiples of 3 between 1 and 100. First is you have to write down all the given, where a sub 1 is equals to 3, your last term is 99, and the difference is 3. Alright, if you analyze the given, we cannot use either of the two equations or the formula because n is missing. So first, you have to find first the number of terms. We're going to identify first how many multiples of 3 there are between 1 and 100. And to solve this one, babalik tayo sa basic. We're going to recall the formula for arithmetic sequence, and that is a sub 1 is equals to a plus quantity of n minus 1 times d. And then from here, we substitute all the given. Your a sub n is equals to 99. Your a sub 1 is 3. And your d is 3. To solve this, we can already find the value of n. Distribute 3 to both terms inside the parentheses. So you have 99 equals 3 plus 3 and minus 3. And combining like terms, 3 minus 3 is 0. So we have 99 equals 3n, and divide both sides by 3. Your n is 33. Alright, so to continue our solution, thus, we can say that there are 33 multiples of 3 between 1 and 100. Since we already found the number of terms, we are now ready to find the sum. And we're going to use either of the two formula because the difference is given and the last term is also given. So for our solution, we're going to use the first formula where a sub n is equals to n over 2 times quantity of a sub 1 plus a sub n. And to substitute, n is 33, a sub 1 is 3, your last term is 99. Solving this, 33 over 2 times 102 will give us 1,683.